Okay, hello everyone. My name is Robert Šefr, and I'll be speaking about our experience with the DNS resolution and the deployment and the usage of the newest features that are available in regards, for example, DNSSEC. So the presentation and our experience is based on the deployment of our technology. We currently serve more than a few millions of people / devices in our networks, and therefore our priority is stability, low latency, and we really focus on the standard compliance. And therefore, we chose as a base for our technology, we chose the NOT resolver from CZNIC, and we are really happy with that and with the cooperation with CZNIC. And our product also focuses on preventing the malicious traffic and the malware originated traffic from the network and the anomaly detection, but I'm not going to speak about that in this presentation. So what I would like to discuss is mostly our experience with NSEC3 aggressive negative caching, and I'll start with a particular topic, which is a random subdomain attack or random subdomain DDoS attacks in the networks seen on the network on the DNS resolution. For those of you who are not experienced with those attacks, we see them basically in any small to medium to large ISP networks. So the attacks are quite easy. The infected client, just tries to resolve different random subdomains for the targeted domain. Here on the example, it's a DDoS target. .com, and it just generates new and new subdomains through the default DNS resolver, meaning the resolver just takes the query and asks the authoritative servers for the response. If you have a botnet large enough, you can take the authoritative server's domain down along with the whole service. So this is what we see for several years, and it's still ongoing. It's still happening. The issue for the resolver itself could be the outgoing traffic, of course, and that these responses are eating up your DNS cache on the resolver, because you are caching even the non-existent domain responses. So it's not something you want in your network, but it's hard to get rid of. One of the possible solutions, or let's say approaches how to defend against the random subdomain attacks, could be DNSSEC aggressive caching. So how do you use it? You know from the authoritative servers that some of the records actually do not exist on the main zone, so you don't have to query the authoritative servers for the particular random subdomains. So you just calculate that okay, this query, this particular record doesn't exist. I don't have to query the authoritative server. I will just respond that this domain doesn't exist, and of course I don't have to store this particular response in my cache. Meaning I'm saving my memory, I'm saving the outgoing bandwidth, and also shielding the upstream authoritative server from the attack itself. There is a really nice presentation from Petr from CZNIC, and they have done a lot of measurements regarding these attacks and the impact of the DNSSEC aggressive caching. So I encourage you to dig deeper into this topic in the presentation. What we have seen this is one of the example of the random subdomain attack. What we have seen in our networks I like this one. I like this one very much. You can see different patterns in this attack. These are individual days, and during the individual days, the client is actually sending different query type as the for the random subdomains, starting with the A queries, continuing with the quote A, and for example the NS queries. So they are changing daily the query types for the authoritative server, and there is the actual pattern they are sending to the domain, which is really, this one is quite awkward. That's why I chose this one. It's changing like MX2, MX2, MX1 something. It looks quite like a code. So if you put it, if you take it, and we were investigating what does it mean actually. If you put it in a music notes, it's actually Beethoven's Ode to Joy. Oh, not really. Okay, sorry, just kidding. But it's just a DDoS anyway. But one of the many, and really we see it throughout our networks. This is the target domain which is targeted. Okay, sadly this one hasn't been protected because it hasn't been signed by DNSSEC. So sadly, I'm not sure whether we want to protect actually such a domain. If you want to win on Galaxy S10, you can. There's a statement by Pauline Collette that she is very happy to won such a mobile phone. Okay, I don't know. It seems that some attacker is targeting another scammer. Okay, anyway, it's hitting your resolvers in your networks, and you don't want that. For the DNS aggressive caching, we also had some issues with the deployment on our resolvers, as actually Not Resolver was the first one to implement the NSEC3 negative caching, and there was a single but quite noticeable issue with the F5 big IP load balancers. What we had, sadly, the F5 big IP load balancers are used by the largest companies and largest organizations. So what we have seen is that the F5 big IP load balancers, they provide faulty response for the NSEC3 in some special cases. So, for example, if you ask the F5, hey, give me an quote A response for domain.com or something, and the quote A records do not exist, it actually replies with the faulty answer stating, for this domain, for this particular domain, let's say domain.com, only the TXT records exist, which is a complete nonsense. But the resolver will remember, okay, I don't have to ask for any other record types other than the TXT, which results in basically DOS state for all the clients which are trying to reach the particular domain. We have seen this. In our networks. It was a bit tricky to analyze because this information stays in the cache just for a brief moment. So to understand what's happening, it took some time, and we have to thank to CZNIC to helping to analyze the issue deeper. The issue was actually hitting, for example, banking, government institutions, etc. So if you are going to deploy the NSEC3 negative caching in your networks, you can be happy with the newest Not Resolver version, which actually circumvents this issue and is aware of this particular problem, and you won't hit the same as we did. this could be also important for the other resolvers when they are deploying this worldwide. Another topic could be the DNSSEC validation itself, the very basic DNSSEC validation, as we are really struggling to provide the best service available. We are monitoring the DNSSEC validation failures in our networks, and what we see, quite a lot, we see domains with expired DNSSEC keys. This is an example. This is a domain, and all of a sudden there is a huge amount of DNSSEC validation failures. The reason is quite simple: the DNSSEC keys just expired, and no one is taking care of that. What we have also seen, and that was much more horrifying, I would say, was a misconfigured TLD. So all of a sudden, in the morning, we just had calls from our customers, ISPs, that their customers are calling them, "Hey, the internet is not working." The usual sentence when there is an issue, and it was mostly from the Slovak customers from Slovakia, and in a few minutes, with cooperation with CZNIC, we analyzed the issue, and we found out that during the DNSSEC implementation in the .sk domain, some of the servers stayed in a misconfigured state, and they had the wrong proofs for the DNSSEC. So we just notified them in a few minutes. They were able to fix it in a few hours, but analyzing this and being sure what's happening was quite challenging, as the responses were really random. It's just 6 out of 8 servers were misconfigured, so it took some time to explain what's happening, and all the situation was quite confusing. Also, there is a big thanks to the DNSWiz tool. I've also discussed with Keith that DNSWiz, it does a really great job at analysis for the DNSSEC. So if you are not sure about any particular domain, if it's properly signed, if there are any issues, you can rely on DNSWiz. There are a few examples, for example, for nic.cz or some broken DNSSEC domains. You can take a look, and you will have a really nice impression of what it can provide to you. And I was wondering actually how many DNSSEC validation failures we have in our networks. And so I estimated, just for this talk, that it's just 0.01 of all DNS queries in our network. So if any one of you is waiting actually to deploy the DNSSEC validation for your resolvers, you don't have to be worried. This is really just a small subset of the whole traffic, but I encourage you to monitor the DNSSEC validation failures, as you can be a few minutes ahead of your customers if there are any issues in your network. So that's all from me. Thank you a lot, and if you have any questions, feel free.
Any questions for Robert?
Roy Adams from ICANN. You mentioned 0.01% DNSSEC errors and DNSSEC related errors. On the list of errors, the type of errors, where does it rank? Is it like lower than completely misconfigured domains, nothing to do with DNSSEC, or is it high up that list? How does it rank?
Okay, it's a tricky question. I would guess more like from the complaints for the end customers. We don't have complaints in regards of DNSSEC. More complaints are going for the completely misconfigured domains and unavailable authoritative servers at all. But in regards of DNSSEC validation failures, we don't process basically any complaints. So that's.
Okay, thank you, Robert.
Thank you.